In this video, we'll be going over the cofunction, identities, as well as the addition and subtraction, or sum and difference formulas. To start off, let's go over the identity formulas. So our first identity is the cosine identity, which says that cosine of theta minus pi over 2 equals sine of theta. And the sine identity says that theta, or sine of theta minus pi over 2 equals negative cosine of theta. Next, we can look at our addition or sum and difference formulas for cosine and sine. So the first one is the sine sum formula or difference formula, which is sine of a plus or minus b equals sine of a times cosine of b plus or minus cosine of a sine of b. Next, we go to the cosine sum and difference formula, which says cosine of a plus or minus b equals cosine of a times the cosine of b minus plus sine of a sine of b. You may be wondering, why does it say plus or minus here in the parentheses at the beginning, and then it says minus plus? This just means that whenever you see a plus in the parentheses, you're going to have a minus in the equation. But if you see a minus in the parentheses, there will be a plus in the equation. So whenever there's a plus in the parentheses, it is a sum. That goes for both sine and cosine. As well as the fact that when there's a minus in the parentheses, it is a difference formula. The only difference is going to be that when it's a sum formula for cosine, there's going to be a negative in the equation, whereas when there is a difference formula for cosine, there's going to be a plus sign in the equation. Now let's go ahead and look at some example or practice problems. So the first practice problem we have is asking us to find the exact value of sine of 135 degrees. So how I like to do this is to follow these steps. I would personally write these down if I were you, just in case for future reference or for your homework. Well, the first step is to split up the angle. So let's split up 135 and see what we get. Well, we want to split it up based on the angles we find on the unit circle. So in our scenario, we're going to do a sum formula, meaning that we want two angles from the unit circle that add up to 135. So we can look at two angles, and in my scenario, I'm going to choose 90 and 45 degrees, because 90 plus 45 is 135, which is the angle which we want to find. So we're going to use 90 degrees and 45 degrees. So now let's write that in our parentheses. Sine of 90 plus 45 degrees equals the value we're trying to find. Well, now we want to try to deal with radians. So let's convert these angles into radians. So now let's look at the unit circle and say, hey, when it's 90 degrees, what's the radian? For 90, it's pi over 2. And for 45 degrees, it's pi over 4. So we'll just substitute those values in. So we said for 90, it's pi over 2. And for 45, it's pi over 4. We're going to add that sign at the beginning, close off the parentheses, and set it equal. So this is our first step done. Now we want to set up a sum or difference cofunction. Well, remember, when there's a plus in the parentheses, it's going to be a sum cofunction. Now, let's go back up and see the base form for the sum sine identity. Well, it says that sine of a plus b equals sine of a times the cosine of b plus cosine of a sine of b. So let's just set that up. So you can see that this would be a and this would be b. Just think of it as the first one being a and the second one being b. All right, so it is sine of a, sine of our a value, which we said is pi over 2. So we have sine of pi over 2 times the cosine of our b value, which is pi over 4, plus our cosine of our a value. And let's just move these steps a little off to the side so we have space. Times the cosine of our a value times the sine of our b value. And again, we just got this base form from up here, and we just substituted the values we found in step 1. Well, now that we have step 2 done, we just set up our sum cofunction for sine. Now we're going to go to step 3. And in step 3, we have to substitute values from the unit circle. So we have the sine of pi over 2 times the cosine of pi over 4 plus the cosine of a times the cosine of b, and cosine of a was the cosine of pi over 2, and sine of b would just be the sine of pi over 4. Okay, so now let's go to the unit circle and look at what is the value when sine is pi over 2. Well, from our previous videos, we know that sine equals our y value, and cosine equals the x value. Based on this, let's look at the unit circle and see what is the y value or sine value at pi over 2 on the unit circle. So let's find pi over 2, which is right up here, and we're looking for the sine value of that. So sine, we said, is our y, which is 1. So let's substitute 1. So I'm going to rewrite it. So we have sine of pi over 2 plus pi over 4. I'm just rewriting what we had at top. Now I'm just substituting values from the unit circle. And we said that the sine value at pi over 2 is 1. So we're just going to add that here. So that equals 1. And this is getting multiplied by the cosine value at pi over 4. And the cosine value at pi over 4. So let's look at pi over 4, which is right here. And we need to find the cosine, which we said is the x value. So the x value at cosine of pi over 4, or at pi over 4, is the square root of 2 over 2. So times the square root of 2 over 2. So this is our first part, and this is being added to the cosine of pi over 2. So let's go back to pi over 2 and look at the cosine value, or the x value. So the x value at pi over 2 is 0. So we have plus 0 times the sine value at pi over 4. And we said sine is y. So at pi over 4, the sine value is square root of 2 over 2. Square root of 2 over 2. Well, let's simplify our parentheses. So in this first one, we have 1 times the square root of 2 over 2, which gives us the square root of 2 over 2, because anything multiplied by 1 is just itself, plus 0 times the square root of 2 over 2. Anything times 0 is 0, so plus 0, meaning that at the sine of pi over 2 plus the pi over 4 is the square root of 2 over 2, because we set this equal to this expression, or this equation, where it says that 1 times the square root of 2 over 2 plus 0 times the square root of 2 over 2 equals sine of pi over 2 plus pi over 4. So we know that sine of pi over 2 plus pi over 4 equals pi over square root of 2 over 2. Well, remember, our equation, or our first question, was in sine of 135 degrees equals blank. Well, we simplified it down to pi over 2 plus pi over 4. And in our final answer, we're going to write sine of 135 degrees, because that was the original question, equals the square root of 2 over 2. This is our first practice problem done, and again, here are the steps that we followed. Next, let's go on to our second problem, which says that we need to rewrite cosine of x minus pi over 4 in terms of cosine of x. All right, let's go ahead and do this. So first off, let's go through our steps. Here are the steps we're going to use for this problem. The first step is to set up the cofunction. The second step is to substitute values from the unit circle. And the last step is to set the coefficients. Now, let's start this problem. Well, first off, we can see that it's a cosine. So we have a cosine cofunction of some sort. Now we need to determine if it's a sum or a difference cosine cofunction. Well, we have a minus, meaning it is a difference. Now, we are going to go back to the base formula for a cosine difference, and let's go see how that looks. Well, we said cosine of a minus b equals cosine of a times the cosine of b plus sine of a times the sine of b. So we have a minus in the parentheses, but a plus in our equation. Now let's go ahead and write this down here. So we have cosine of x minus pi over 4, and it is a difference because of this minus. So now we have cosine times the value of a, and remember, a is this first value and b is the second value, so it's cosine of x times the cosine of our b value, which is pi over 4, cosine of pi over 4, plus, remember, because in a cosine, if there's minus in the parentheses, plus in the equation. So we have plus sine of our a value, which is x, times the sine of our pi over 4. Now, let's go to and see what step we just completed. We just completed our first step. We just set up the cofunction. Now, we need to substitute all the values from the unit circle. Well, on the unit circle, we obviously don't have a value named x because that's just a variable. But we do have a value for the cosine of pi over 4 and the sine of pi over 4, don't we? So let's go into our unit circle and see what the values are at those two places. Well, the cosine, remember, is our x value at pi over 4, is the square root of 2 over 2. So we can write that in. So now we have this, and it's equal to cosine of x times, we just said the cosine of pi over 4 was square root of 2 over 2 according to our unit circle. So that is our first part. And we're adding that to sine of x. Again, we don't have a value of x on the unit circle. And that is being times by the sine of pi over 4. Remember, sine is the y value. At pi over 4, our y value is the square root of 2 over 2 again. So we have times the square root of 2 over 2. And this again equals the cosine of x minus pi over 4, our original question. And remember, our third step is to set the coefficients. Well, by that we mean anything times by something is going to be having a coefficient of that number, or it's being multiplied. A coefficient is just something you're multiplying by. Well, since we don't have a cosine or a value of x on the unit circle, and x can be almost any number, we are just going to set the square root of 2 over 2 as the coefficient of cosine of x. Well, that will look something like this, where cosine of x minus pi over 4 equals square root of 2 over 2 times cosine of x plus square root of 2 over 2 sine of x. This and this, these are both just the coefficients of those cosine of x and sine of x. And this would be your final answer for the question to rewrite in terms of cosine of x, the equation cosine of x minus pi over 4. I hope this part was helpful. And now lastly, we're going to do one more question. And in this last question, we have to solve for all solutions. This is a much different way or a different approach of solving or dealing with cofunctions. So here are the steps for this problem. Step 1 is to determine the type of cofunction. Step 2 is to simplify the parentheses. Step 3 is to set the parentheses equal to the answers from the unit circle. Step 4 is to divide by the coefficient of x on both sides. Step 5 is to add 2 pi k. And step 6 is to divide 2 pi k by the reciprocal of x. Now, let's begin with this question. Well, remember, the base form for cosine and sine are really crucial to remember for these types of problems, because you have to first determine if it's a sum or difference, but also you have to know if it's a sine sum or difference or a cosine or sum of difference. So in this one, we have sine times cosine. Let's go up and see which one had sine times cosine. Well, we can see that cosine had cosine times cosine at the beginning, but sine had sine times cosine. So now we know it's a sine, right? Because we can see the terms were sine and cosine instead of cosine, cosine. And the question here, and the question down here, we have sine times cosine. Well, now we can see that there's a minus in the equation. And we know that if there's a minus in the equation, there's going to be a minus in the parentheses for a sine equation. So we're going to assume it's a difference sine co-function. Okay, so now we have done step 1. Now that we have determined that it is a difference sine cofunction, let's look at the basic form one more time. So we're going to have sine of a minus b equal to sine of a times the cosine of b. Okay, And that is going to be subtracting the cosine of A times the sine of B. Now, if we follow this base formula and we compare it to this equation we have in the question, we can see that this is our A, that's our B, this is our A, and that is our B. Well, now think about it. If our parentheses looks like this, where it's A minus B, and we need to rewrite it for step 2, or simplify the parentheses, we want to have it where it's A minus B, again, since it's a difference formula. So, we have sine of our A value, which is 3x, minus minus our B value, which is 6x. And that is equal to the equation we see up here. Now, we need to look at the equation and see what we can do. And now we need to simplify the parentheses in step 2, because we just had we just did step 1 where we determined the type of cofunction, and we did the parentheses, but now we need to simplify it. So 3x minus 6x is sine of negative 3x, right? That is equal to the equation we see up there. And now, since it's equal to the equation, and we know that equation equals to the square root of 2 over 2, we can set this sine of negative 3x equal to square root of 2 over 2. Well, now that we know that sine of negative 3x equals the square root of 2 over 2, and we have a negative inside the parentheses, we should also remember that there are odd and even identities, which for sine says that if there's a sine of negative theta, it equals negative sine of positive theta. So we could also rewrite this as sine of negative 3x equals negative sine of 3x. And since the negative is on the outside, that would make our answer negative as well, meaning that since we have a negative sine of theta and it equals to the square root of 2 over 2, we're going to move this negative to the other side. We're going to divide both sides by negative 1, meaning this would be negative 1, or we'd multiply by negative 1 on both sides. So that means our sine of sine of 3x now really equals the square root of 2 over 2. And now that we have that, we're going to go to our unit circle and look where our sine value is the negative square root of 2 over 2, and then we'll go from there. Well, if we look at our unit circle, we can see that negative square root of 2 over 2 is found at 5 pi over 4, as well as 7 pi over 4. So those are going to be our two answers. And this is step 3, where we're setting our parentheses equal to answers from the unit circle. So we just said that sine of 3x equals 5 pi over 4, as well as 7 pi over 4. Now that we have done step 3, let's look at number 4. Number 4 says to divide the coefficient of x on both sides. So the coefficient of x. So actually, in step number 3, we were also supposed to do this. We're going to ignore the sign, and we're going to set 3x equal to 5 pi over 4, as well as 7 pi over 4. So let's do this one at a time. So let's do 3x. 3x equals 5 pi over 4, and the coefficient of a number is just what's being multiplied, or what it's being multiplied by. In this scenario, x is being multiplied by 3, coefficient is 3. We divide both sides by 3, so then we get x equals 5 pi over 4 over 3. And when you're dividing a fraction by a number, you are just multiplying by the reciprocal of the denominator, reciprocal of this, which is 3. The reciprocal of 3 is 1/3. So you're doing x equals 5 pi over 4 times 1/3, and 5 pi, and you're just doing denominator times denominator, numerator times numerator. 5 pi over 4 times 1 over 3 is 5 pi over 12. So this is your first answer. And then let's do the second part, which was 3x equals 7 pi over 4. So 3x equals 7 pi over 4, and we're going to follow the same steps we just did with 5 pi over 4, where we're going to first divide by the coefficient, which is 3. Again, you're dividing a fraction, so you're just doing x equals 7 pi over 4 times 1 over 3, giving us 7 pi over 12. This is the second answer. And so we just did step 4. And now we need to add 2 pi k to both of our answers. So that means we have x equals 5 pi over 12 plus 2 pi k, as well as x equals 7 pi over 12 plus 2 pi k. Let's see what the last step says. Last step says to remember to divide by the coefficient of x, or divide 2 pi k by the coefficient of x. So remember the coefficient of x was 3. We're going to divide 2 pi k by 3, and same goes for this one. So for the question that says sine of 3x cosine of 6x minus cosine of 3x, sine of 6x equals the square root of 2 over 2, and we're trying to find the solutions. The solutions we found were x equals 5 pi over 12 plus 2 pi k. Let's write that down up here. So x equals 5 pi over 12 plus 2 pi k. And the second answer we found was x equals 7 pi over 12 plus 2 pi k over 3. And we forgot the over 3 up here as well. So we have x equals 5 pi over 12 plus 2 pi k over 3. And these are the two solutions for this question right here. I hope this video helped, and if you believe it did, please consider to like and subscribe, and remember to hit the bell icon for future notifications. And again, if you want to take notes on any part of this video, feel free to rewind. For future videos, remember to comment, and I'll definitely try my best to make a video for that topic. Thank you.